So today's lecture is going to be on algebraic expressions and identities. So if you want to learn more, stay tuned. So in today's lecture, we will be looking at the fundamental concepts of these expressions, addition and subtraction of algebraic expression, multiplication, division of algebraic expression, and algebraic identities. So let's get started. First, we'll look at some fundamental concepts. So first, what is a constant? A constant is something that has a fixed value. It can be, say, a number or any kind of a number, say 7, 3, minus 2, 5 by 7, root 2, anything of these sorts are constants. So a variable is a symbol which can be given any numerical values. Next, let's look at an algebraic expression. So basically, an algebraic expression is a collection of constants and variables and are connected by one or more operations, say addition, subtraction, multiplication, and division. And all of this forms an algebraic expression. So this can be of the form, say, minus 7x square y cube plus 5x square y. This is an algebraic expression connecting constants and variables together with some sort of an operation, multiplication or addition or anything of that sort. So that's how an algebraic expression works. So there are various types of algebraic expression. The first one is the monomial. So basically, these algebraic expressions only have one term. So say if we only have 7x squared by into y cube, that would be a monomial. Second one is a binomial, and this would be these two expressions together. So that would be a binomial expression. Then again, we have a trinomial and then a multinomial. So these all follow the same trajectory as a monomial or a binomial expression. Next up, we have a factor. Factor is basically when, say, two or three values, say 7x squared, y cube, is multiplied together, and this is the entire product, and one part out of it would be a factor. So for say 7x square y cube, factors would be 7, then it would be x square, y square, y cube. All of these values would be a factor of this algebraic expression. So in this we have, say, a constant term. So a constant term would be something, say 7, because that has a literal value and that does not change, but values of x square, y cube, they can change. So therefore, in this situation, a constant term would be 7, or it can be any other numerical value based on whatever algebraic expression you have. The next one is the coefficient, and this is any kind of factor that is a non-constant term. So the constant was 7 or any other numerical value, and a non-constant term would be a coefficient. So in this case, it would be x squared y cube. These would be the coefficients of the algebraic expression. So following the different kinds of coefficient, we have this terminology called like and unlike terms. So basically, what happens in like terms is that if two algebraic expressions have the same number or same literal coefficients, then they are called like terms. So let me just give examples of like and unlike terms. So like terms would be something like 5x square y and 8x square y. So these would be like terms. And for unlike terms, something that does not resemble the same would be, say, 5x, 3y, or 7z, 5x squared y. All these are unlike terms because the literals in all of these are different. Finally, let's start with polynomials. An algebraic expression is called a polynomial if the powers of the variables involved in it in each terms are non-negative. So let's look at that. So whenever we think about polynomials, we have a word or a key point known as degree. And this is basically the greatest power of the variable in a polynomial. So let's start with the first one where we have polynomial in one variable. So we can have some examples like 7 minus 3x, and that is a polynomial with a degree of 1. We can also have 5t squared minus 2 by 3t plus 8, and this polynomial has a degree of 2. We can also add some expressions where we have polynomial of degree 3. Let's write that down. That is degree of 3. And that's how it goes on. You can write it as much as you want. Let me give you an example where an expression looks like a polynomial, but it's not that. Let me show that to you. Let's take an example of 5x squared minus 3 by x plus 6. And this is not a polynomial. If you know the answer, let me know in the comments below. So basically, this is not a polynomial because x here is in the negative power. So if we convert this, this will get 3x to the power minus 1. And that's not the condition of a polynomial. Therefore, this whole expression turns out to be not polynomial. So let's look at polynomial in two variables. So for this, the number of degrees would be the greatest sum of all the degrees of every variable. So let's look at some examples. So say we have 8x cubed y squared minus 5x squared y cubed minus 2 by 3 x y cubed minus plus 7xy minus 1 by 5. So this is a polynomial in two variables x and y. So let's find the degree of its terms. So the first term 8x cubed y squared, it would be 3 plus 2, that is 5. For 5x squared y cubed, it would be 2 plus 3. For xy cubed, it would be 1 plus 3. For xy, it would be 1 plus 1. And the next one, with no variables, it would be 0. It would be 5, 5, 4, 2, and 0. And that's how polynomial in two variables, two or more variables are. So let's start with some of the basic questions on addition and subtraction of algebraic expressions. So firstly, there are two kinds of methods when we are looking at addition or subtraction of two algebraic expressions. So the first one is the horizontal method, where we collect different groups of like terms and then find the sum of each group. And there's a column method where we write each expression and add them in a separate row. So we'll try both of them and then you'll see how it goes. So let's take a first example. So in this question, we have to add these three values. So this time we'll try the horizontal method. So basically, we'll just group these terms together and show you how that's done. So we'll just first try to find anything of the similar type. First, let's try x squared. So we have 3x squared, and then we have minus 4x squared. We'll group them together. We can add that. Let's look at xy. Do we have any other xy? So we have minus 5xy, and we have minus 9xy, and we have plus 7xy. We'll add those together. So minus 5xy, minus 9xy, and plus 7xy. Next, let's look at y squared. So we have 4y squared. We also have another y squared. So we have 4y squared plus y squared. And then we are left with only the coefficients. We have minus 1 plus 5 minus 13. So this gives us minus x squared minus 7xy plus 12y squared minus 9. And that's how our horizontal method works. In the next question, we'll also try this column method. So we'll just write these down as they are, one under the other. So 3x squared minus 5xy plus 4y squared minus 1. Have this up as a first expression. Then we have 7y squared. We'll write this below 4y squared minus 9xy. Write this below 5xy. Then we have plus 5. That would be below 1 minus 1. Next we have 7xy minus 4x squared plus y squared minus 13. Let's add these all. This comes out to be minus 9 plus 12y squared minus 7xy minus x squared. And that's how we solve it. Let's look at another question, but this time we'll do subtraction. We have to subtract 5x cubed minus 3x squared minus 8 from 2x cubed minus 5x squared minus 11x plus 2. So because it says that we have to subtract a from b, so from needs to be the bigger one. So from would stay on the top. And we'll use the columnar method because that makes it a lot easier. We have 2x cubed minus 5x squared minus 11x plus 2. And we use the columnar method. So we have 5x squared x cubed minus 3x squared minus. Now we need to change the signs before e. So this becomes minus, this becomes plus, and this becomes minus. So this becomes first, sorry. So plus 8 plus 2 would be 10. That is plus 10. We have minus 11x anyways. Then we have minus 5x squared plus 3x squared. That becomes minus 2x squared. And then we have minus 5x cubed plus 2x cubed. And that comes out to be minus 2x cubed. And that's how we find the subtraction of any algebraic variable from each other using the columnar method. Let's next move on to the multiplication of algebraic expressions. So basically in this, we need to follow a couple of rules. Let's look at that. So basically these two rules states that for the product of two factors with the same sign would be positive. So I'll just write that down as plus and plus would be plus, and also minus and minus would be minus. And the next one is the product of two factors with unlike signs is negative. So plus and minus is minus. So that's that. The second point is if say x is a variable and m and n are two integers, then x to the power n into x to the power m is equal to x to the power m plus n. So these are the two rules that we need to follow, and we'll start with some examples then. So let's try this. So we need to add all these three values together, but before that we need to figure out this multiplication. So now we'll first start with the multiplication of each and every element. So we'll multiply p with p minus q. So this gives us p square minus pq. Q minus r gives us q square minus qr. And r into r minus p gives us r square minus pr. So let's add these together. So we have p square minus pq plus q square minus qr plus r square minus pr. So that is our sum. Now let's move on to a more difficult version of this, and that is multiplication of a polynomial by a polynomial. So we'll start with another example. So we'll multiply. So we need to multiply this factor by this factor. So we'll follow the very simple arranging of polynomials, and this arrangement works in terms of descending power of x, and then we multiply them. So let's start. So we have 5x to the power 4 minus 2x cubed plus 3x minus 4. We'll reverse the one for the next one. So we have minus 7x squared minus 3x plus 2. So we'll multiply these. So let's multiply each and every one of these. So we'll start with minus 7x squared, and then we'll multiply it with each and every part of the first algebraic expression. So minus 7x squared into minus 4 becomes 28x squared. Minus 7x squared into plus 3 would become minus 21x cubed. Minus 7x squared into minus 2x cubed would give us 14x to the power 5. 14x to the power 5. Because I'm leaving this space because we might have some values with x to the power 4 as their variables. And then we have minus 7x squared multiplied by 5x to the power 4. That comes out to be minus 35x to the power 6. Next up, we will multiply minus 3x with all the values in this equation. So we have minus 3x into minus 4, which comes out to be minus 12x. Sorry, that comes out to be plus 12x. So we'll put that behind x squared. Next, we have minus 3x into plus 3x. That comes out to be minus 9x squared. Then we have minus 2x cubed into minus 3x, which comes out to be plus 6x to the power 4. And then we have minus 3x into plus 5x to the power 4. That comes out to be minus 15x to the power 5. So now we'll multiply plus 2 with all these values, and that comes out to be plus 2 into minus 4. That comes out to be minus 8. Plus 2 into plus 3x comes out to be plus 6x. Plus 2 minus 2x squared x cubed comes out to be minus 4x cubed. And then plus 2 into minus 2x cubed, plus 2 into minus 5x to the power 4 comes out to be plus 10x to the power 4. So now we'll have to add all these values together, and that comes out to be minus 8 plus 18x plus 19x squared minus 25x cubed plus 16x to the power 4 minus x to the power 5 plus and minus 35x to the power 6. Minus 35x to the power 6. And that comes out to be our final answer with this multiplication. So that's how we do our multiplication of polynomial by a polynomial. So that's all for today. Please don't forget to like, share, and subscribe to our channel for more.